In the following video, we will be computing an integral so that we could calculate the area between those curves. Now, to start with, I would like to sketch those curves first. So now it tells that y is equal to x cubed, y equals to minus x, y equals to 1. So let's start from the easy one. Y is equal to 1. So basically, this is a straight line. Now we'll be sketching x cubed. Well, we might remember that x cubed has such a curve. Now we'll be sketching minus x, and we can see that the slope here is negative. That is why if we would be having a positive slope, we'll be sketching it this way, but since we have a negative slope, we'll sketch it the inverse of this sketch. So basically, I now have the entire sketch. Sorry. Okay. So the area that we need to calculate is between those curves. So we will be calculating the shaded area. Now, in order to calculate this, we might divide those area into two parts, but that would be a bit more scrupulous than it would be integrating from left to right. If I were to integrate from left to right, it will be one integral. If I integrate it from from bottom to top, then I will have to divide it into two parts. That is why we'll be integrating from left to right. Now, in order to integrate from left to right, we will need to have this xy1 and xy2, and we'll be integrating this expression. Now, in order to get those two functions, then we simply need to express x in terms of y. So from here we can easily notice that x is equal to y to the power of 1 over 3. And here we can see that x is equal to minus y. And this y equals to 1 will help us to establish our domain of integral. So basically, I will have our integral goes from 0, since the point of intersection is 0, as we can see in the graph. You can solve this point of intersection analytically as well, but here it's kind of very easy to see that they have intersected at point 0. So we'll be integrating from 0 to 1, and now we will have to integrate from left to right. So basically, I will have to integrate from y to the power of 1/3 minus y dy. So as you can see, this will be easily integrated. So we will simply obtain 1, 3 plus 1, which will give us 4 over 3, and thus we will have this in front, and then I will have y squared over 2. Y squared over 2. So we will have our integral from 0 to 1. So basically I will have to plug in only 1, and the answer will be in our hands. So we will have 3 over 4 plus 1 over 2, which will yield us 4, 3 plus 2, 5. 5 over 4. So this is how you can integrate from left to right. In many cases, it's much more comfortable to integrate this way rather than to divide the area